Chlorine is classified under Division 1 Flammable Substances and class of flammable gases. Fluorine is also classified under Division 1 Flammable Substances and class of flammable gases. Since both chlorine and fluorine are flammable gases, they are both classified as Class 1, Division 1. Therefore, the rooms containing these substances should be classified as Class 1, Division 1 hazardous locations and require equipment and wiring that is specifically approved for such locations. This includes electrical switches, lighting fixtures, motors, and ventilation systems. Additional consideration should be taken into account. Firstly, the room should also have adequate emergency ventilation to remove any hazardous gases in the event of a leak or spill. Secondly, the rooms should be isolated from other parts of the facility to minimize the potential for hazardous gases to spread. Thirdly, proper personal protective equipment, or PPE, should be available for personnel entering these rooms. Regarding ventilation, the ventilation rate of 2.5 air changes per hour may be sufficient to prevent the accumulation of hazardous gases under normal operating conditions. However, additional ventilation may be required if the rooms are not adequately sealed or if there are potential sources of leaks or spills. The fire resistance rating of the construction separating the two rooms should be sufficient to prevent the spread of fire or hazardous gases in the event of an incident. A specific fire rating is not specified. It should be determined based on the specific risks associated with the facility. Understanding hazardous location classifications is crucial for ensuring safety in facilities that handle flammable substances. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where the hazard is likely to exist under normal operating conditions, frequently exist because of repair or maintenance operations or because of leakage, or in which equipment breakdown or faulty operation might release flammable concentrations of flammable gases or vapors, and might also cause simultaneous failure of electrical equipment. The presence of both chlorine and fluoride, classified as flammable gases, necessitates a Class 1, Division 1 designation for the respective storage rooms. This classification demands stringent safety measures to mitigate the risk of ignition and explosion. Electrical equipment installed in Class 1, Division 1 locations must be explosion-proof, meaning that it is designed to contain any explosion that may occur within its enclosure and prevent the ignition of surrounding flammable atmospheres. This includes lighting fixtures, switches, receptacles, and motors. Wiring methods must also be appropriate for hazardous locations, typically involving the use of rigid metal conduit or other approved methods to prevent the escape of flammable gases or vapors. Ventilation is a critical aspect of hazardous location safety. Continuous ventilation helps to dilute and remove flammable gases or vapors, preventing them from reaching explosive concentrations. A ventilation rate of 2.5 air changes per hour may be sufficient under normal operating conditions, but it is essential to consider potential sources of leaks or spills. If the rooms are not adequately sealed, or if there is a risk of releases, additional ventilation may be required. Emergency ventilation systems should also be in place to quickly remove hazardous gases in the event of a leak or spill. These systems should be capable of providing a high rate of air exchange to rapidly dilute the concentration of flammable gases. Proper personal protective equipment, or PPE, is essential for personnel entering Class 1, Division 1 locations. This may include respirators, protective clothing, gloves, and eye protection. The specific type of PPE required will depend on the specific hazards present and the tasks being performed. Regular training should be provided to personnel on the proper use and maintenance of PPE. Isolation of hazardous locations is another important safety measure. Separating the chlorine and fluoride storage rooms from other parts of the facility helps to minimize the potential for hazardous gases to spread in the event of a release. Fire-resistant construction, such as concrete or masonry walls, can provide a physical barrier to prevent the spread of fire and hazardous gases. The fire resistance rating of the construction should be determined based on the specific risks associated with the facility. Regular inspections and maintenance are essential for ensuring the continued safety of Class 1 Division 1 locations. Electrical equipment should be inspected regularly to identify any signs of damage or deterioration. Ventilation systems should be inspected to ensure that they are operating properly. Leak detection systems should be tested regularly to verify their functionality. Any deficiencies identified during inspections should be promptly corrected. In addition to the specific requirements for Class 1 Division 1 locations, it is important to comply with all applicable codes and standards. These may include the National Electrical Code, or NEC, NFPA 496, standard for purged and pressurized enclosures for electrical equipment, and other relevant standards. It is also important to consult with qualified professionals such as electrical engineers and safety consultants to ensure that the facility is designed and operated in accordance with all applicable requirements. The specific risks associated with chlorine and fluoride storage should be carefully considered when determining the appropriate safety measures. Chlorine is a toxic and corrosive gas that can cause respiratory irritation, skin burns, and eye damage. Fluoride is also toxic and can cause a variety of health effects, including skeletal fluorosis and neurological damage. The potential for leaks and spills of these substances should be carefully evaluated, and appropriate measures should be taken to prevent them. In summary, the classification of chlorine and fluoride storage rooms as Class 1 Division 1 hazardous locations necessitates stringent safety measures to mitigate the risk of ignition and explosion. These measures include the use of explosion-proof electrical equipment, adequate ventilation, proper personal protective equipment, isolation of hazardous locations, regular inspections and maintenance, and compliance with all applicable codes and standards. By implementing these measures, it is possible to ensure the safety of personnel and the protection of property in facilities that handle flammable substances. Furthermore, consider the specific properties of chlorine and fluoride. Chlorine gas is heavier than air and can accumulate in low-lying areas, increasing the risk of exposure. Fluoride, while often stored as a liquid solution, can release hydrogen fluoride gas under certain conditions, which is also hazardous. Therefore, ventilation systems should be designed to effectively remove both heavier than air and lighter than air gases. The choice of materials for construction and equipment should also be carefully considered, as chlorine and fluoride can be corrosive to certain materials. Stainless steel, certain plastics, and other corrosion-resistant materials may be necessary to ensure the long-term integrity of the facility. Emergency response plans should be developed and implemented to address potential leaks, spills, or other incidents. These plans should include procedures for evacuating personnel, containing the release, and neutralizing the hazardous substances. Regular drills and training exercises should be conducted to ensure that personnel are familiar with the emergency response procedures. The fire resistance rating of the walls separating the chlorine and fluoride storage rooms is a critical factor in preventing the spread of fire and hazardous gases. The specific fire rating required will depend on the potential fire hazards in the facility, the amount of flammable materials stored, and the proximity of other buildings or structures. A qualified fire protection engineer should be consulted to determine the appropriate fire rating. Consider the potential for static electricity to build up in the storage rooms, especially during the transfer of liquids or gases. Static electricity can be a source of ignition in flammable atmospheres. Grounding and bonding techniques should be used to prevent the accumulation of static electricity. All equipment and conductive materials in the storage rooms should be properly grounded to a common grounding point. Bonding jumpers should be used to connect any isolated conductive parts. Regular monitoring of the atmosphere in the storage rooms can help to detect leaks or spills early on. Gas detectors can be installed to continuously monitor the concentration of chlorine, fluoride, or other hazardous gases. These detectors should be equipped with alarms to alert personnel in the event of a release. The location of the gas detectors should be carefully selected to ensure that they are effective in detecting leaks in all areas of the storage rooms. Proper labeling and signage are essential for communicating the hazards present in the storage rooms. Warning signs should be posted at the entrance to the rooms, indicating the presence of chlorine, fluoride, and other hazardous substances. The signs should also include information on the potential health hazards and the required personal protective equipment. All containers of chlorine and fluoride should be properly labeled with the name of the substance, the hazard warnings, and the contact information for the manufacturer or supplier. Access to the storage rooms should be restricted to authorized personnel only. A system of access control, such as key cards or passwords, can be used to prevent unauthorized entry. Regular audits of the storage rooms should be conducted to ensure that all safety procedures are being followed. These audits should be performed by qualified personnel who are familiar with the hazards of chlorine and fluoride. The results of the audit should be documented and any deficiencies should be promptly corrected. The design and operation of a water fluoridation facility require careful consideration of the hazards associated with the chemicals used. By following these guidelines and working with qualified professionals, it is possible to ensure the safety of personnel and the protection of the environment. Remember to always consult the most current edition of the National Electrical Code, or NEC, and other applicable codes and standards for specific requirements.